Hey, what's going on, guys? Hey, this is your 1.3 complex conjugates and dividing complex numbers. All right, let's go and get started. A couple things here that we got to address is our I can statements, guys, for today. All right, I can find a conjugate of a complex number. We'll talk about what a conjugate is in a second. I can use a conjugate to find a quotient of complex numbers. We're going to talk about that. And I can rationalize the denominator of imaginary numbers in the denominator. So the main thing to remember here is this little statement right here. It says that a complex conjugate of a complex number, a plus bi, is a minus bi. Guys, literally all you do is look at the complex number, a plus bi. All right, and what you're going to do is you're going to change the sign in front of bi. So let's say a plus bi was what you had on the paper. You would change the sign in front of the bi to a minus bi. All right, this is the conjugate of this one. Okay, let's say hypothetically on the paper it was a minus bi, and it said find the conjugate. Well, look at bi. You would change the sign in front of the bi, the imaginary part. So you have a plus bi. All right, that's the complex conjugate. All right, sometimes, guys, you'll get caught up and it'll not be written in standard form. It'll look like this. Let's say negative bi plus a. And it goes, find the complex conjugate. Well, guys, look, this isn't in standard form. All right, so if you write it in standard form, all right, a minus bi, excuse me. All right, the minus is in front of bi. Now find the complex conjugate, a plus bi. All right, so make sure you put it in standard form first. All right, put it in standard form first, and you'll always get that part right. The complex conjugate is literally changing the sign in front of the imaginary part. Now, that's the complex conjugate, guys. This right here just goes into more depth. It just talks about, hey, here is a complex number. Here's the conjugate. All right, they're related because they're conjugates. Notice the only thing that changed was the sign in front of the complex part. See, -5, that's the real number, -5. That didn't change. All right. By the way, guys, I know I sound terrible. All right, but the show must go on, so we're going to continue. So take this right here. It says, find the complex zeros of the quadratic function. Find the complex conjugate. All right. Find each complex conjugate. Well, again, here's a complex number. The only thing that should change is the sign, the operation in front of the complex part or the imaginary part. So you have 8 plus 5i. The conjugate will be 8 minus 5i. Over here, you have just an imaginary part. Guys, there's no real part here. All right, so this complex number is just an imaginary part. So again, this is a positive 6i. All right, what needs to change to have the conjugate? The sign in front of it changes. Since this operation is positive, right, this is positive, we're going to change the operation to a negative. So guys, the conjugate of 6i would be negative 6i. Now, the next thing I want to talk about, guys, is recall that the expression in simplest form cannot have square roots in the denominator. All right, so remember when you have a fraction, guys, all right, let's say it was like 3 over the square root of 3. Guys, you can't have a radical or a square root in your denominator. You have to rationalize this, all right? And that's what we're going to do with complex numbers. You cannot have some number or some expression over, like let's say 3 plus x, over 3 plus 4i. You can't have a complex number in the denominator. All right, you gotta rationalize this word right here. Rationalize the denominator. All right, very important word right there. So we're gonna rationalize this, and the way you rationalize this is you multiply the top and the bottom by the complex conjugate of the denominator. So see, this denominator is a complex number. We're going to take its conjugate and multiply it to the top and the bottom, all right, of this fraction. All right, and when we do that, it's going to eliminate the conjugate in the denominator, because this brings me to this example over here. If you take the product of a complex conjugate, a product of complex conjugates is always a real number. Again, if I take these two complex conjugates, all right, these complex conjugates, 3 plus 4i and its conjugate, 3 minus 4i, excuse me, and I multiply them, I will get a whole number. For example, 2 plus 4i multiplied by its conjugate, 2 minus 4i, is going to give me 18. All right, if I multiply these conjugates, I'll get an actual real number. Okay, so let's go ahead. We just got to do some examples. All right, if you get caught up at any time, a couple of things I want you to see right here. This is step by step a problem that's done for you, so you can see it. All right, they take the denominator, which is a complex number. Remember, we can't have a complex number in the denominator, so we're going to multiply by its conjugate at the top and the bottom. Excuse me. Remember, when you do that, it's going to give you a real number in the denominator. All right, and then you just simplify it from there. All right, simplify it from there. The reason this simplifies is because, let me show you. The reason it simplifies, guys, is because, let me make it bigger so you can see. Right here, and oh, you know what I just noticed? The answer's cut off. This should be 12 minus 5i over 26. All right, but here's what happened. If I factor, remember that word factor. See how that's positive, that's positive, that's positive. All right, the factor, all those numbers I've been coming is 2. So if I factor out of 2, or divide everything by 2, right, when you factor out, this is 12 minus, divide that by 2, 5i, and if you divide 52 by 2, you have 26. All right, so yeah, 26 times 2 is 52, so the 2's are canceled, and I'm left with 12 minus 5i over 26. Okay, so on your paper, put that over 26. All right, now use this, guys. These are the steps. These are literally the steps written out for you. Use the steps, all right, as you practice. All right, the only way to get better, guys, is to practice. Okay, so let's do some examples. Let's turn over to the back. I'm gonna go to the next slide here. Here, for example, C, find the, what's that, simplify. All right, so this one, we're gonna start off by first identifying that, look, there's a complex number in the denominator. You cannot have a complex number in the denominator. So step one, what's step one then to rationalizing this this fraction right here? Step one, let's look back at it, because I want to show you how you use it. We got the problem, it's already written. Write the complex conjugate in the numerator and the denominator. So I'm going to write the complex conjugate in the numerator and the denominator. Well, this is 5i, so we change the sign in front of the imaginary part. Since this is positive 5i, the conjugate is negative 5i. So I'm going to write that at the top and the bottom. All right. Now, the next step says we need to, if you flip over, it says multiply the numerator and the denominator by the complex conjugate. So I'm going to multiply this by negative 5i and this by negative 5i. And when I do that, we're gonna distribute negative 5i right here. So you get negative 5i times 3, that's negative 15i, and you get negative 5i times positive 10i. So negative 5i times positive 10i is a negative 50i squared. All right, negative 5 times 10 is negative 50. Oops, see that right there, what I just did? Caught myself with a little mistake, but I'm gonna correct it right now. 50i squared, okay? Now, the bottom down there, you have 5i times negative 5i. Well, 5 times negative 5 is negative 25, and I times I is I squared. Look, I did it again, guys. Here we go. Negative 25 I squared, okay? Now, we're going to the next step. It says simplify the I squared to negative 1. That's step number 5, if you flip it back over. So we're going to simplify the I squareds to negative 1. All right, these I squareds right here. So we have, I'm going to go up here. Good job, first. Negative 15i minus 50 times negative 1. Because remember, I squared is negative 1. That's the top. At the bottom, you have negative 25 times negative 1. Because again, I squared is negative 1. Now, combine, well, let's simplify, then combine like terms. You have negative 15i. You have negative 50 times negative 1. Well, that's positive 50. Now, all I did with the top right here is I rewrote it in standard form, A plus BI. Remember standard form? All right, A plus BI, well, in this case, A minus BI. All right, so this is standard form. And now at the bottom, you have negative 25 times negative 1. That's actually positive 25. Now, step 7, simplify using common factors. All right, let me change colors. We're going to simplify this. To simplify this, look at this expression right here. 15, negative 15, and 25 all have a factor of 5 in common. So I'm going to factor out a 5. Oh, wait, before I move on, y'all notice how multiplying, remember, as if you multiply the conjugate, all right, multiply conjugates, you'll always get a real number. See how we got 25 down here in the denominator? This is the same thing as that, all right? Now, back to what I was saying. All these have 5 in common. So I'm going to factor out a 5. All right. Now, factor all this by 5. 50 divided by 5 is 10. Negative 15i divided by 5 is 3i. And 25 divided by 5 is 5. Okay. So that way I can cancel these 5s out when I factor out the 5s. Now, here's my final answer. 10 minus 3i all over 5. This is the final simplified version of our original problem. I'm going to erase this real quick so you can see what I'm talking about. Here's the original problem, 3 plus 10i over 5i. This is simplified. All right, this is the simplified answer. Okay? So now, I'm going to go ahead and do part D for you. If you need to refer back, just remind it, guys, have a look. All right? I'm erasing this so we can have space to write. Guys, this is 100% correct. All right? So don't try to comment and go, this is wrong. No, that was right. All right? Now, this problem here, okay, step 1 again. The problem's written for you. Step 2, write the complex conjugate. Good job, first. All right, write the complex conjugate in the numerator and denominator. So guys, looking at this problem, remember, for the conjugate, you're going to change the sign in front of the imaginary part. So negative 5i is the imaginary part. We're going to conjugate that to positive 5i. All right? That way, Remember, that's not the conjugate. All right, that's not the imaginary part. This is what we change. All right, this is what we change. So now we're going to distribute that 8 over here, and we're going to FOIL this denominator, okay? So now, that foiling goes back to 1.2, all right? 1.2, so make sure you understand 1.2 so you can use those skills for 1.3. All right, we're building, so we're going somewhere. So right here I have 8 times -2, that is -16, and 8 times positive 5i is going to be positive 40i. Down at the bottom, we got a FOIL. Now remember, when you multiply 2 conjugates, you're going to end up with a real number. So -2 times -2 is positive 4. -2 times 5i is -10i. -5i times -2 is positive 10i. And -5i times a positive 5i is a -25i squared. All right. Now, ask yourself, what is step 3? Well, we already did that part. Step 4, simplify the I squared to -1 and simplify. All right. So we have I squared down at the bottom. There's no I squares up here, so that stays the same. All right. So
you see, let's see, -16 plus 40i. All right, that doesn't change because this is not an I squared, so that stays the same. Now right here, we're going to simplify this denominator. If you see 10i minus 10i, that cancels, guys, to be 0. So we're left with 25, and I squared is -1. Okay. So now, the I just wanted to fix that real quick. Now, if we simplify this stuff further, you see that -25 times -1 is actually positive 25. So I have -16 plus 40i all over 4 plus 25. Okay? And now when you add that up, -16 plus 40i all over 29. Alright, and this, guys, is going to be our final answer. None of these factors have anything in common, like we did the previous problem. 16, 40, and 29 don't have a common factor, so that's it. Now, we have one more problem before the U tries, so let me clear this out right here so we can have space to work. Alright, for this problem, guys, we need to make sure we know that this is the complex number in the denominator. It can't stay there. So we're going to multiply by its conjugate in the numerator and the denominator. So 4 plus 2i at the top and bottom. Now, with these guys, because they're both binomials, we're going to FOIL the top and the bottom. So at the top here, we're going to get 2 times 4 is 8, and 2 times 2i is 8i. I'm sorry, 4i. Oh my gosh, look at me. 2 times 2i is 8i. Oh man, I wrote it again. 4i. Alright, and then 8i times 4 is 32i. And finally, 8i and positive 2i is going to be 16i squared. I gotta remember, man, I and I gives you I squared. Down at the bottom, 4 times 4 is 16. 4 times positive 2i is 8i. Negative 2i and 4 is negative 8i. And negative 2i and positive 2i is a negative 4i squared. Now, keep in mind, guys, that I squared equals -1. So this will become -1. fact, I'm just going to use the highlighter. I like that better. All right, this becomes -1, and this will become -1. All right. So you have 8. Oops. There we go. 8 plus, like terms right here, 4i and 32i gives us 36i. And we have plus 16 times -1. Let me write that better. I think I can write that better. Ooh, not all that. There we go, -1. Okay. Now at the bottom, we have 16. Combining like terms, 8i minus 8i is 0. And we have -4 times -1. Okay. 4 times -4 times -1. That's -1. Now we go ahead and simplify everything. 16 times -1 is -16. Okay. So that's 8 plus 36i minus 16. And down here I have -4 and -1. That's 16 plus 4. So finally, 8 minus 16 is -8 plus 36i. Remember, I put that like that because it's a plus bi, standard form. And 16 plus 4 is 20. All right. Now, last step is to reduce. All these numbers here are divisible by 4. All right. So you have -4. No, actually, since we took out the 4, it's just going to be 4. 4 times -2 plus 9i all over 4 times 5, because again 4 times 5 is 20. Alright, and 4 times -2 is 8, and 4 -8, and 4 times 9i is 36i. So the 4s are going to cancel. Alright, so I'm left with -2 plus 9i all over 5. Okay, this is our final answer. Now, there are these U tries of these 3, and to upload. No, I'm gonna write the answers in. Now, I'm gonna go ahead and put the answers in for you for the U try. So for U try 1, 2, and 3, here are the answers. And for U try 4 through 6, here are the answers. Okay, give those a try and bring me questions on Monday. All right, bring me questions on Monday. Okay. Hey, hope this video helps.